form-based world, we take, tables, these rigid structures, tree views, visualizations, the math notation, stuff like that. I mean, that's common in more application-like things. Okay, summary. This is the same slide as in the beginning, right? We want to have all these nice things. The idea then to get expressivity for core domain knowledge is to build languages for the domain using notations that are close to the domain. I think I've given you a bunch of demos that show what I mean by that, right? The user-friendly notation is just that. The testing, I didn't show that in the live application because I didn't have the time to build it, but some of the screenshots had testing aspects where you could actually test your business rules right there. Meaningful analysis, things like type checks. We think it's boring because every IDE has done it all the time. It's new for most of these systems. And then, of course, we use code generation. I didn't talk about code generation. Of course, from all these systems I've shown, we generate code, Java code or C# code that runs in a data center and actually computes insurance contracts or executes the business rules in case of this Dutch benefits application, stuff like that. But code generation is boring, right? We've done that forever. We've solved the problem. It works. I don't have to talk about it. But of course, it's part of the story. So this is important. There's no AI, right? I'm not suggesting that the changes in the world somehow magically get into the software. It's still manual work by the business people, but they now have tooling that is kind of helpful and not in the way. And for us as developers, I think it's a good idea to invest in thinking about how can I build these arrows, right? What do I have to do as a software engineer to